All right, we're gonna get started on lesson 11. What are perfect squares? So things that are perfect squares, guys, 1 times 1, 2 times 2, 3 times 3. Just out of curiosity, how far can you get?
Forever.
How far can you get without using a calculator? As a class. 1 times 1,
1.
2 times 2,
4.
3,
9.
4,
16.
5,
25.
6,
36.
7,
49.
8,
64.
9,
81.
10,
100.
11,
121.
12,
144.
13,
169.
14, it's actually just that.
56.
It's just opposite. And then 15 is 225. And you can keep going. Usually the first 20 are pretty common. So the first question is saying, what expression can I put in for A that makes each side true? All right, so here's my A. What could I plug into A to make both sides equal? Okay, so this one is x squared. What would I need to put in for A to make that side the same? I would plug in x and it's x squared, exactly the same. Okay, how about this one? This side is 3x squared. What could I put in for A to make it the same?
Whatever, 3
3x.
times.
3x.
3 times.
3x. 3. What can I put in for A? This side I got 7x and 7x. 7x, that's the same as 7x squared. 25x squared, so what could I put in for A? 25x. 1/4 x squared, this side is A, so just 1/4 x. 6.
X plus 1.
X plus 1. Last one?
2x minus 9.
There you go.
Wouldn't it be,
2x minus 9.
because it's always squared.
Yes. All right, question number 1 for part 2. Directions state, write, or each expression is written as a product of factors, write the equivalent expression in standard form. So what is 3x twice mean? Remember, that does not mean 3x times 2. It means 3x times 3x, which is 9x squared. 7x times 7x is?
7x squared.
Nope.
14x.
49. There's a common mistake, right? 7 times 2. Nope, it is 7 times 7. X plus 4 times x plus 4.
X squared plus 8x plus 16.
There you go. Okay, why don't you try the next 3 on your own? Again, if you still need a diagram, please make one. Next one's x plus 1 times x plus 1. Good? Should be getting really good at these by now. I've done a lot of them. Should have x squared plus 2x plus 1. x squared minus 14x plus 49. X squared plus 2nx plus n squared. Questions?
Oh, that's.
Where'd you get 2x?
We're at here?
Yeah.
nx and nx would be 2nx's. Combined like terms. So why do you think the following expressions are called perfect squares?
They're all squared.
Because they're multiples of each other.
Yeah, so the first one is x plus 3 times x plus 3, which is x plus 3 squared. Second one there is x minus 8 and x minus 8, which would be x minus 8 squared. Next one is x plus 1 6, x plus 1 6, which is x plus 1 6 squared. So it is the same term twice. Also can take the square root of the first term and the last. So we're going to look at two different ways to do these on page 235. Okay, Han and Jada. So let's look at Han's first. Let's discuss what Han is doing here. So we have x minus 6 squared. He wrote it out twice. Foiled it, or drew the diagram. Moved the 25 over by subtracting it. Wrote the factors. Okay, so let's do that for this one as well. So write it twice. Foil it. I'll let you guys do that for me. Foil it or draw the diagram. Anybody?
Y squared minus 10y plus 25.
Okay, I'm going to subtract 49 and bring that over to the left. 25 minus 49 is negative 24. Factors of 24, where the negative is 10 bigger.
Negative, or factors of 24.
Wait, so if there's a middle term, does that mean we have to, oh wait, never mind, sorry.
Factors of 24 that differ by negative 10.
6 and 4.
Nope. If you're adding them, that would be fine.
Oh, then.
I got opposite signs.
Then plus 6 minus 4.
Nope.
Plus 4 minus 6.
Nope. That'd be 2 and negative 2. I need to get the negative 10.
12 and 2.
12 and 2. Those would be my two answers. All right, well, let's look at Jada's method. Jada seems to be quite a bit easier. A lot less work there. What did Jada do?
7 equal to 5 would be.
Why?
Just to take the square out.
Yeah, took the square root off. Square root of 25 is 5 and negative 5.
But don't you?
Oh,
Why don't you,
So then you solve them both.
wouldn't you have to unsquare what's inside of Oh, I guess you do, because you just take away, because it's a perfect square.
It's
So
a
not
perfect
like
square.
5 times -5, it's.
Okay, so we're gonna do the same one up here using Jada's method. If, oh, that's 49. If you have two perfect squares, you can use Jada's method. Take the square root of both sides.
What is that, a 49?
That's supposed to be 49. Square root of 49 is 7 and
7.
-7.
-7. So I set that factor here equal to 7 and -7. Solve it. Add 5. Add 5. And you'll notice you get the exact same answers as we had right here. How sweet is that? Only true if they are perfect squares. Something's square, the other one's a perfect square as well.
But you don't actually know if you do it that way.
You don't actually know if you do it that way. I don't understand the question.
You don't know what's inside the parentheses then. Or I guess you do.
You just take the, yeah, I mean, if it's the same thing squared, you take one away.
But it's the opposite, because the 12 is the negative inside of the parentheses.
Yes. Okay, so we're gonna do that. Next one, we're gonna do it both ways. Maybe you wanna go to the back of the book there where you got more room, because it's kinda tight. If you can write small, you can probably do it. But I want you to do it both ways.
Which one?
Top right.
Okay. Are we gonna do the bottom two too, or can we write in that area?
I'll probably do one of those for sure. We'll see how it goes. Give you a chance to start it first. Follow Hans' way first. And then do it Jada's way. Okay, if you want to check, Hans' way is done up there. Wrote it twice, FOILed it. Subtract the 9 to make it equal to 0. Factor.
Oh, okay, subtract 4.
Jada's way. Notice you should get the same answer. So Hans' way is what we've been doing. Jada's way now is a shortcut.
But only for perfect square?
Only for perfect squares.
Can you just look at this number and then put this one?
You have to subtract
Oh, so subtract
16 minus 9.
So this was -9.
All right, there's two more there. You want to try the fraction one or decimal one?
Decimal.
Decimal.
Okay, do the same thing.
For both of them.
Both. Well, the decimal one. Both ways. Decimals, you can see, do make it a little trickier, but the process is exactly the same. Same with fractions. And again, you should get the same answers. Questions on either one of those, Hans or Jada's way? See the similarities? See how much easier the one on the right is? Yeah, that's only if there's perfect squares can you do that. Perfect squares, again, has a nice square root to it.
So,
Okay, let's take a peek at the homework. 236 again shows you some perfect squares, definition of that. Let's take a look at the homework, starting on page 237. Caleb, you were asking a question
on the lesson.
on the lesson. First one, select all that are perfect squares. Did a few examples of those today. Question number 2, it says each diagram represents an expression or a perfect square. Complete all the cells in the last table. And then you're basically describing a pattern. Looking at those three when they're filled out, how do those, what's the top left always have in common and bottom right have in common and so on. Okay, 2 more questions are on the next page. Question 3, solve. Okay, that's just what we got done doing. If you prefer Jada's method, you can do that, remember, as long as it's perfect squares. Question number 4, explain or show. for number 4, explain or show. 5, Han's not done, finish it. And then Jada comes in and solves it her way, using Jada's reasoning and so on. I think you can handle that one with no issues. And question number 6, review from unit 4. I'm not gonna remind you, I'm hoping you can remember. What is the absolute guessing error? And then fill it out on the chart. And that is it, only 6 questions today. And granted, those solving ones take a little time, but only 6 questions up through page 239 today.